Welcome to this video on graphing systems of equations. In this video, you'll learn how to find the solution to a system of linear equations by graphing. And we already know how to do a lot of this, so this should be a pretty easy activity for us. So, a system of equations. What that means is we have two or more equations using the same variables. So when we're graphing, we're going to end up having two lines on the same graph. If you want to solve a system algebraically, which is what we're going to do after graphing, the coordinate point xy that makes both equations true. So it's a point where the lines meet. Okay, so that gives you a little hint here. If we're going to graph it, the coordinate point where the two lines intersect, that is the point that they share that makes both of the equations true. So there's three types of solutions that we run into while graphing our systems of equations. One is you can have intersecting lines, and what that means is you're going to have lines that cross each other. Where these two lines cross is a point. That point is the solution. Okay? You can only cross two lines one time because they're straight, so they're not going to cross each other again. So anytime you have two lines across, one point will make both equations true. The other thing you can have happen is you can end up with parallel lines. Well, parallel lines never cross. Let me give us some notes here. So they never cross, which means they have no solutions, because they don't share any points in common. Okay, one thing that's important to note about our parallel lines is they will always have the same slope. Okay, then we have a situation that's a little more unique. It's when the same line, and what that really means is you have a line, and then you have another line that's the exact same line. Okay, so it's on top of each other. And that's going to have infinite solutions because they share all points. Every point will make both equations true because they're the same equation. All right. An important thing to note of that is they're going to have the same slope, but they're also going to have the same y-intercept because they're the same line. Okay, those are just some things that you might notice along the way. So let's take a look. We're going to graph our systems. There's three different ways we're going to talk about, but we're going to start with graphing. So the easiest way to graph a line is to put it into slope-intercept form. So you'll want to, if it's not already in slope-intercept form, you're going to want to rearrange your equations to be in the y equals mx plus b form. And then we're going to graph our lines and identify the solution by naming the coordinate point where the lines intersect. So let's take a look at our first one here. So you have this fancy bracket, and it's just saying we have these two lines, and we're going to go ahead and graph them on the same graph together. So our top line has a y-intercept of -8. Okay. And then it has a slope of 1. There's an understood 1 in there. So it's up 1, right 1, up 1, right 1. So here's our slope. So we're going to finish graphing this line first. And then we're going to go to our second line. So our second line has an y-intercept of 1. So we're going to start graphing right here. And then the slope is a -2 divided by 1. So that says go down 2 and right 1, down 2, right 1, down 2, right there. They're going to end up crossing. Let's go ahead and put our graph in there because that's the point that they share. Okay, now the solution is just the name of that point. So that point is 1, 2, 3. So my x value is 3, and then my y value is 1, 2, 3, 4, 5 down. So 3, -5. If I plug 3 in for x and -5 in for y, it will make both of those inequalities true. All right. Let's try our second one. It's nice when they're already in slope-intercept form. It makes it a little bit simpler. So my y-intercept is at 9. And my slope is 1/2. That says rise 1 and run 2. Well, I ran out of space to work, but I went up and right so I can go down and left to count it going the other direction. Okay, so let's finish this graph before we move on. All right, so now let's look at our second equation, or here. We have a y-intercept of 6 right there, and a slope of -1. So this is down 1, right 1. See how I'm going away from the other graph? So I went down and right. I can just go up and left, and I can get back to it. We shared that point right there. Let's go ahead and graph it, finish it. And what is the name of that point? It looks like we went -2 and then up 8. So our solution is -2 and 8. We plug that x and y value in here and we get the true statements on both. All right, let's flip this over to the back. All right, let's look at number 4 on the back. One of these is already in slope-intercept form, so I'm going to go ahead and graph that one first. It has a y-intercept of 2 and a slope of -1/2. So that says down 1, right 2, down 1, right 2. Just keep following your pattern. Okay. So I'm going to draw this in. Now, the other equation. The reason I didn't start with this one is because it's in standard form. We need to solve for y to get it out of standard form. So I have x plus 2y equals 4. So I'm going to subtract x from both sides. And I get 2y equals -x plus 4. I want y by itself, so everything gets divided by 2. And my second equation is y equals, there's a 1 in front of here, -1/2 x plus 2. Does that look familiar? Does it kind of look like that one? I wonder what that means. So let's take a look. I start at 2, and my slope says go down 1 and right 1. So here and here and here and here and here and here. It's actually the same line. So we're going to draw that one in too. So how many points do those lines share? They share all of the points because they're the same line. So that means the number of solutions it has is infinite, with our infinity sign, because they share every single point in common. All right. Now I want to try number 6. Okay, so 6, we have one of the equations already ready for us, so we'll start there, starting at where y is 5. Put your point, and your slope is a +1, so up 1, right 1, up 1, right 1, up 1, right 1, down and left, down and left, down and left. Okay. So there's this line. Now, the other line is in standard form, so we have to rearrange it so it's in slope-intercept form. So we want y alone, so let's move the x over to get started. That's a -y equals -x plus 2. Okay, I don't want to know about -y. There's really a 1 at -1, so I'm going to divide each thing by -1 to get y alone. And I have y equals -1x minus 2. So I'm going to start off at -2, but I have a slope of +1, which is up 1, right 1, up 1, right 1. So it looks like they don't cross, but here's what you have to verify. They look pretty parallel, but you need to take a look at their slope. This top equation has a slope of 1, and the bottom equation also has a slope of 1. That means because they have the same slope, they are parallel. So that means they'll never cross. So they have no solutions because they share no points in common. All right. We'll save the other two for class. We'll see you there.